Good evening, everyone. This is Sarel van Greenen, aka Mr. VG, and today I made 100% sure that my mic is working. It's awesome to have you all here. I wish I could be sitting in a class with all of you, but it is fantastic to have this privilege of spending this next 45 minutes to 60 minutes just going through some amazing trigonometric questions. Now, all of these questions, ladies and gents, have come from either previous year's exam papers or Mr. Mboweni. Again, a brilliant question that I'm also going to roll in there. I encourage each and every one of you to please send in questions. I would love to answer them. Our next session, and I'll talk about that at the end, will be about geometry. Woo! That favorite Euclidean geometry. I encourage you, please send in your questions. The link is down below where you can send it, the email address. Now, I'm not going to spend much time, getting through all of those things at the moment. First of all, before I start with the questions, I just want to quickly just refresh your memory because I know matric is a bit rough. So let's start first of all by looking at some theory. Now, I'm not going to spend lots and lots and lots of time explaining and going over the theory. For that, I encourage you, go and have a look at the videos that are available under the trigonometry playlist. There I do some fantastic explanations about the cast diagram, negative angles, how you handle them, the identities, cofunctions. If you've never understood cofunctions, please go and watch that video. Now, I encourage you, these notes that you see on the board, or on your screen, these notes are available for free. They are available on the theory booklet, or in the theory booklet that you can download from the program. Where can I find the program? The link is down below in the comment section. Please go and download it, distribute it to as many of your friends as possible, and let's dig in. Let's have some fun. So I'm going to start off this evening's streaming by looking at a question that I found, I think, from a previous year's GDE paper. Now, this is not a really challenging one, but I do think that it is important for us to just start it kind of slowly before we go to the really fun ones. So let's start with this first question. Again, I encourage you, I implore you, hit the pause button when you see the video or when you see the problem and try it yourself. And then you continue going further. And let's have fun. Let's start with our first question for the evening. Our first question for the evening states, consider f of x equal to sine of x plus 25 cos 15 minus cos x plus 25 sine 15. And the first question is determine the general solution of fx equal to tan of 165. Now, if I look at this at 5.4.1, I'm going to start off by saying, okay, you know what? If I make fx equal to tan of 165, I would like to go down this route of thinking, but I don't want to work with something as complicated as that big expression for fx. So again, just looking back at my theory, it kind of looks familiar. Which identity does it look like? If I've got a sine cos, and then I've got cos sine with the same angles, well, that is exactly the sine compound angle, where x or alpha is that one there, and y is 15. So I can compress fx into a sine compound angle. So inside the compound angle, I'm going to have x plus 25 degrees as my first angle. And because it is a minus, and with sin, it stays the same, then I'm going to have 15 degrees there. And this I make equal to tan of 165. So just to recap what I did, I compressed this into a smaller, more manageable identity. In other words, I'm left with this very basic equations. Sine of x plus 10 degrees equal to tan of 165. Now, just please, I want to do something for the future reference. Let's compress this 165. Let's make it between 0 and 90. Compress is not the right word, but reducing is. So I'm going to work in the second quadrant where it's 180 minus 15 degrees, which means tan in the second quadrant, well, that is negative tan of 15 degrees. The reason why I do this, and you don't actually have to do this, is I want to know, is it positive or negative? Because that is going to give me the quadrants. Please, ladies and gents, whatever method your teacher uses for you to solve equations, trig equations, I encourage you to follow that. I'm going to do it my way. Please do it your way. Do it the way your teacher told or showed you. For me, I like to do reference angle, which is shift sign, or actually in mathematical terms, arc sine of tan 15 degrees. Now, if I look at that value, if I calculated it correctly, is about 15,54 dot, dot, dot. Some of you might ask, but so what on earth happened to the negative? Remember that the negative actually just shows you, according to the cast diagram, it shows you in which quadrants I work. Now, with sine being negative, I am going to work in T and C. So I'm going to work in quadrant 3 as well as quadrant 4. So by working in quadrant 3 and quadrant 4, in quadrant 3, I'm going to take my angle x plus 10 degrees is 180 degrees plus this reference angle plus k times 360, which leads me, if I take the 10 over and it becomes a minus, I'm going to be left with 185,54 degrees plus k times 360. Super simple and straightforward. In quadrant 4, I'm going to have x plus 10 degrees equal to 360 minus that 15,54 plus k times 360, which means, again, if I take that minus over and it becomes a plus, or the plus becomes a minus, my apologies, you end up with 334,46 plus k times 360 degrees. There we go. Now some of you might say, but wait, so you forgot something. I know, I'm testing you. I promise I didn't. K is an element of Z. Remember to put that in. You don't get a mark for putting it there, but you lose a mark. Oh, my apologies. I see that I didn't. There we go. I didn't show you the screen with my working out. So let's just quickly recap what I did. My apologies for showing the theory there. I'm going to quickly recap and show you what I did. Don't worry. There we go. So let me quickly show you what I did. So you'll see there that I made my sign into a single identity. Then on the right hand side, I did my, let me speed this up a little bit. There we go. Becomes negative tan of 15 degrees. Working out my reference angle. There we go. Showing me my quadrants that I work in. Quadrant 3 and quadrant 4. Calculating my missing angle that I have now. There we go. And there's my first set of solutions. My second set of solutions in the fourth quadrant. There we go. Okay, and then finishing it off by saying K is an element of Z. There we go. Now we are on the same page. My apologies for that technical glitch there. Now, ladies and gents, remember this is a general solution, meaning it is all possible solutions. I could now make K anything I want to. I could make K 0, 1. It's the number of revolutions or periods that I actually add. I hope that you're with me. If you're struggling a bit, please, I encourage you, go and talk to your teachers. Go and talk to them and make sure that you've got this. Now, I'm going to look at question 5.4.2, and I'm going to try and spice it up a little bit. So if I look at question 5.4.2, and I look at fx. Now, let's just remember that fx I reduced into, let me just write it here, into sine of x plus 10 degrees. Meaning it is the sine graph, the normal sine graph, moved 10 degrees left. So if they ask me, determine the values of x in the interval this for which fx has a minimum value. I'm going to go towards my graph of fx. So I'm going to start between 0 and 360. Okay, my graph is going to go up, down, up again. Intervals here at 90. So it's going to have at 270, it's going to have a minimum value of -1 because the amplitude is still 1. But remember, this, ladies and gents, is just the sine x graph. But now, if I move it 10 degrees left, I'm going to take the whole graph and just shift it 10 degrees left. So now my minimum also shifts 10 degrees left. So my minimum is going to be at 260 degrees. And what is the minimum value? -1. I hope everyone's all right with that. Okay. Now, for the sake of time, I prepared another one. But I'm going to see at the end whether there's more time to actually do this one that I want to do. So let's just go on to my second question. Again, pause if you are struggling to understand what I did. Pause, try it again, ask questions. And if you're really getting stuck, send us an email. The link is down below in the descriptions. Let's have a look at the second question sent in by Mr. Mboweni Tepang. Tepang sent this one in. Given the tan of theta times by sine of 2 theta plus 3 cos squared theta over sine theta equals to this. Number 1, prove the identity. What I would like us to do, because I know that you guys, my students struggle. My students struggle with proving left equal right. So what I kind of do is I like to have a recipe that works, but I'm going to show you guys the basics. If I've got to prove a left equal right, my thought pattern is number one, change tan of theta and sine of 2 theta. The reason why I pick them is simply because they only have one set of identities. To just quickly share with you what they are again, you'll see there that tan of x is equal to sine of x over cos of x, and at the top right you've got sine of 2x equal to 2 sine x cos x. Okay, let's get back to the question. So I'm going to go left hand side, and on my left hand side I'm going to change tan of theta into sine of theta over cos of theta. Then I'm going to change the sine of 2 theta into 2 sine theta cos theta. Again, I would only change these. If there was a cos 2 theta, I leave it alone. I don't change it because I don't always know to what I want to change it. It has 3 options. But let's quickly go back now to the sum. And then I'm left with plus 3 cos squared theta over sine of theta. At this moment of time, I would actually tell my students to put it over the LCD inside the brackets. But I'm going to do something a little bit different. I'm going to, so usually, I'm saying this usually, I would tell you to find the lowest common denominator. Die KGV, die kleinste gemeene noemer, die KGN vir die Afrikaans sprekende oukies. So the LCD inside the fraction would be sine of theta, but I'm not actually going to do that. I'm going to be sneaky, okay? I am actually not going to do this, which is my normal step 2. What I'm actually going to do is I'm going to multiply the sine theta over cos theta into the brackets. The reason why I'm deviating from what I would normally do is I am having the foresight that because this 2 sine theta over cos theta, or this 2 sine theta cos theta is over 1, the cos theta divides away with that cos theta, leaving me with an absolutely gorgeous sine theta times by 2 sine theta, which is 2 sine squared theta. Plus, if I do the same now with the back one, I see that that sine divides away with that sine, again leaving me with no fraction at the back. So, and actually awesome, that cos, let me try just a different color here. Let me go for pink. That cos divides away with one of those, leaving me at the back with simply 3 cos theta. Lovely, beautiful. But now we are sitting with an issue. We are sitting with an issue that my left is not equal to my right yet. So here is something where I would say step 3 of my usual modus operandi would be to look for now square identities, ladies and gents. I actually don't just make a sum bigger. The whole mission of trigonometry is making the sum smaller. But in this case, if I look where I want to go, I want to get to a place where I only have causes on the right hand side, which means That sin squared on the left-hand side, I do not want to use. I don't want to have a sin squared there. So let's go back to my theory. If I want to change sin squared x into cos squared x, I can use the square identity of 1 minus cos squared. So in other words, I can change this sin squared into 1 minus cos squared theta. Please do not just change it all willy-nilly. Do not just change it because you feel like it. Change it because you are going towards something. Remember that monkey that you want to find, in this case, only has cos thetas in it. So I don't want sin squared in there. So let's multiply out, which is 2 minus 2 cos squared theta plus 3 cos theta, which leads me, if I just rearrange this, into 2 cos squared theta plus 3 cos theta plus 2. Oh my goodness, that is the right-hand side. Boom, I've got it. Simple and straightforward. I'm saying simple and straightforward until you don't get it right, then it is not so much fun. It is not so much fun when you're not getting it right. This is going to take some practice for you to get used to this. I implore, always look, where do you want to go and how can I get there? That monkey behind the mountain. Let's have a look at 5.4.2. Both IEB and GDE love questions like questions 5.4.2, where you've got to first of all prove something, then secondly they ask you hence or determine the general solution. So if I look at question 5.4.2 and now they tell me solve that equal to 0. So if I look at this, I've got to constantly ask myself, how does this relate back to my specific given identity or my proven identity? Now for me to look at this, I see that I've got a left-hand side that's exactly the same as that left-hand side at the bottom. So in the place I can say use 5.4.1 and I've got negative 2 cos squared theta plus 3 cos theta plus 2 equal to 0. So in other words, I've got, let's just divide by negative, so I've got 2 cos squared theta plus or minus 3 cos theta minus 2 equal to 0. Now here comes something and you guys are not going to like me for it. But that's okay. It's okay. I want to share this with you. If you are struggling with factorizing trigonometric identities or equations, my encouragement to you as a student is make cos theta equal to, let's say, little a. But now this you do on the side. You don't have to show this to the examiner. You do it on the side. And then you substitute that, well, basically into your expression. So 2a squared minus 3a minus 2. Well, that's a simple thing to factorize, or at least it's supposed to be simple. If I factorize this correctly, I've got 2a and a. I've got negative 2. Ooh, let me write that a bit bigger. Negative 2 and plus 1. Let's just check it. 2 times by negative 2 is negative 4. Plus 1 is negative 3. Yes, it works out. Now I'm going to use this and I'm going to go back to my equation. So I'm going to say, therefore, I've got 2 cos theta plus 1. And I have cos theta minus 2 equal to 0, which leads me to find the two sets of equations, cos theta equal to negative 1 over 2, or cos theta equal to 2. Now, automatically, ladies and gents, cos theta cannot be 2. You can go and try and find a reference angle, and your calculator will give you math error. Now, the reason for this is, remember, that the cos theta graph has a highest point at 1. In other words, it will never go up to 2. So therefore, cos theta cannot be equal to 2. There's something that you might learn from me today, is I relate everything I do back to graphs. And I love that, because then it makes visual sense. For instance, why cos theta can't be 2 or 3 or negative 2. I don't like to just punch stuff into my calculator and get answers. I like to visualize everything. Now, in this case, my negative tells me that I'm going to work in quadrants 2 and 3. My reference angle, you must be able to do without a calculator. Future engineers and medical students and actuaries, you've got to be able to do it without a calculator, because in your first year at varsity, in calculus, you're not allowed a calculator into your exam. So I would ask myself, which angle for cos, special angle, gives me a half? Well, that one specifically is my 60 degrees, because that is root 3, 1, and 2. So it's 1 over 2. So my reference angle is 60 degrees. This leads me to say in quadrant 2, I've got theta equal to 180 minus 60 degrees plus k times 360, which is 120. And I'm going to skip a step or two. Please forgive me. This is just for the sake of time. In quadrant 3, it is 180 plus 60, which leads me to 240 degrees. And for both of them, plus k times 360. And what must I never forget? K is an element of Z. Ooh, let me write that a bit bigger. I am trying to go way too small here. K is an element of Z. Please do not lose that 1 mark. This is lovely. This is lovely. But now I think we're done with the warm-up. I hope you are warmed up now, because now we're going to jump in and have some fun. This next question I got from a previous year's exam paper. Absolutely beautiful. Prove the following identity. Sine of 90 plus theta times by sin squared theta minus 180 minus cos cubed 180 plus theta all over cos theta minus 2 sin squared theta equal to cos 2 theta. That's a mouthful. Please do not let a sum like this freak you out. It's really not necessary. So what we are going to have a look at is we have to go towards our 2 basic first steps in a sum like this. And our 2 basic first steps are, step 1, I want the angles between 0 and 360. That's my step 1. And when I'm done with this, step 2 is going to be, I want my angles between 0 and 90. So that is my first 2 steps. No matter what kind of a trig sum I see, that's my first 2 steps. And the amazing thing is, it scores you more than half the marks in an exam. Ladies and gents, I just want to quickly talk to you for a moment before I go back to the sum. A very important thing in this regard is that you make 100% sure that your angles, your signs are perfectly the correct sign. In other words, positives and negatives. It's got to be correct. If the moment you make one sign mistake, a plus which should be a negative or a negative which should be a plus, you would only be able to get about halfway through the sum. And after halfway through the sum, I can guarantee you, you're going to get stuck. So please, use your cast diagram wisely. Use your cast diagram perfect before you worry about all the rest. Because that's where I see most of my matric students slip up. So let's get back to that question. Step 1, okay, that 90 degrees tells me that I am going to work with a cofunction, which means sine is going to change into cos of theta, definitely. But now 90 plus is in the second quadrant according to my theory. Let me just quickly point it out here. You will see in the second quadrant there's 90 plus theta. And it's always asking myself, where is the original one is positive there. Okay, so I've got that down. Now sine squared of theta minus 180. I know that a lot of teachers take the long road, which is taking out a negative common or those kind of things. I've got a different way of doing this that for me just I like to use because it's simple. I add 360 degrees. The reason why I do that is because, and you'll see I do this, sin theta, negative 180 plus 360 is plus 180 degrees. And I put my square outside. The reason why I put my square outside is that I don't forget that no matter what is inside the bracket, I've got to square it. Now I'm going to do exactly the same, but now with a cos, so it's going to be cube outside. If I look at cos of 180 plus, that's negative cos theta because it's in the third quadrant. And this is all over cos theta. And then I have this lonesome little 2 sine squared theta here at the back. I'm not going to worry anything about it. I'm not even done with my first 2 steps. So let's just continue that cos theta is nothing for me there. Then I've got negative sin theta in the third quadrant, but it is squared. Then I'm now going to go a cube. A negative cubed is a negative, cos cubed theta. If I put this all over cos of theta. The beautiful thing about this is that square makes that negative a positive. And that's why I move the square outside. Because if you don't move the square outside, you might be tempted. You might be tempted to forget that that negative is also squared. So this means I've got cos theta times by sin squared theta plus cos cubed theta all over cos theta. And I mustn't forget at the back my negative 2 sin squared theta. Negative 2 sin squared theta. At the top, I can take out a cos common, leaving me with sin squared theta plus cos squared theta, all over cos theta, which means that cos divides away with that cos, they become 1. And sin squared plus cos squared is also 1. Oh, this is absolutely lovely. So I'm left with 1 minus 2 sin squared theta. Now, I'm not going to burst your bubble at this moment, or maybe I am. I don't know where you're going with this. But what I want to show you is actually, I'm then going to move over to the right-hand side. And please understand that you can move from left over to right as long as you clearly write for the examiner. I'm working left-hand side all the way down. And then I'm going to work on the right-hand side. If I look at cos of 2 theta, oh yes, look where I want to change it. I want to change it to something that has only a sin in it. So I'm going to choose 1 minus 2 sin squared theta. Absolutely brilliant, because now my left-hand side is equal to the right-hand side. Some of you might cry, sacrilege, sir. You're not allowed to work on both sides. Ladies and gents, you are allowed to work on both sides. You are allowed to work left, move over to right, as long as in the end your left-hand side expression is equal to what you have on the right-hand side. It's going to make manipulation quite a bit easier if you do it this way. Now, ladies and gents, I'm going to have lots of fun with this next one. This next one, ladies and gents, I found from last year's IEB exam paper. Hold on to your hat, hold on to your seat, buckle up, because this is a fun question. This question states that a metal frame is built to help provide some shade to a triangular piece of land, ABC. Now, ABC are on the same horizontal plane, so that's awesome for us. Then, it also then says that AC is 7, BC is 8, and AB is 10. AF, BG, and CH are vertical poles. Okay, that is awesome, because that tells me there are 90 degrees there. And AF is equal to BG, equal to 3 meters. CH is 2 meters. HF and FG are metal poles that complete the frame. Now, before we go to anything, before we actually look at the question, I just first of all want to look at what is kind of implied in this question. The one thing that is implied in this question is that FG is also 10 meters. It's the same as that one. The reason why this is because both AF and BG are the same height. Be careful of thinking that these two are equal and those two are equal. That's not the truth. The reason why it is not the truth is simply because that is 3 meters and 2 meters, which means this is a slanting down side. And think about a piece of wood that one corner has been cut off. That is what this thing will look like. So now I'm going to go towards calculate the area of FGH. So that slanted triangle there. So what I did, and now this is something that I like to do, is the monkey behind the mountain. Now if I look at my theory for area, The formula for area says that it's a half of AB sine C. In other words, the half of one leg times by a half of the other leg times by sine of the angle in between. So if I look at this specific problem, if I want to calculate the area that is colored in green, or that's striped in green, I would like to have that little side there, that side there, and the angle in between them. And that is where this is going to take me. So if I draw this triangle, the slanted one, I like to do this. Before I start, I like to draw everything separate from one another. So F, G, and H. Okay? If I look at F, G, and H, okay, that is now the slanted one that I'm going to look at. I know that that is 10 meters. So I need three things: that side, and I need that angle in between. So something that we can kind of do now, I'm just going to erase this so I can work on my sketch, is I'm going to look at my two sides. I'm going to look at the side on the left, so I'm going to look at AFHC. So like that. So there is A, F, H. Just want to make sure that I've got it right. H and C. That is 2 meters. That is 7 meters. And that is 3 meters. So now the question is, I need the length of that specific side. So what I'm going to do is I'm going to construct my own little triangle, because that is also 7 and that is 1. Now you might say, where do I get the 1 from? Remember, the whole side is 3 and that little 1 is 2. So in other words, that is 1. By using Pythagoras, I can actually now get FH. FH squared is 1 squared plus 7 squared. So FH is the root of 49 plus 1, which is 50. I'm going to repeat this exact same process, but now I'm going to look on the triangle, or that one on the right. So in other words, I'm going to look now at, oops, there's 3 meters, that is B, H, no, sorry, B, G, H, C. That is 8 meters, which means, again, let me not forget that there's a 2 there. If I construct my triangle, I'm going to get 8 and 1 again, because that is 2. And if you repeat this process, you can find that GH is also, by using Pythagoras, root of 65. Now that is brilliant, because that means I have FH, which is root of 50, and I have GH, which is root of 65. And now I've got to find little h, which means I can actually work in this triangle FHG. And if I look at my theory, I'm going to jump over to the theory quickly. Whenever I'm working with 3 sides, I'm going to go towards my cosine rule. So if I look at my cosine rule in triangle FGH, so I'm going to work here in triangle FGH. it says that 10 squared is equal to root of 50 squared. Just want to make sure that I don't go over the other one. Root of 65 squared minus 2 root 50 root 65 multiplied by cos of angle FHG. And all I'm going to do now is I am going to solve this cos of FHG. So I'm going to take the 100 squared is 100 minus root 50 squared is 50. Root 65 squared is 65, so minus 65 over, okay, let me not jump too far ahead, equal to negative 2. Oh, seems like I am running out of space here. Let me quickly move this down a little bit. Done, there we go. Negative 2 root 50 root 65 cos of FHG. Then I'm going to divide both sides by this expression, negative 2 root 50 root 65 over negative 2 root 50 root 65. Therefore, I'm just going to finish it off here. I've got cos of FHG, angle FHG, being, let me see, where did I calculate it? Some value, I'm not exactly sure what that value is. Okay. Let me quickly get it for you. Sometimes the wonders of technology also brings you down to your knees. Okay? So if I look at this, if I calculate quickly that other side, I've got 100 minus 65 minus 50 all over negative 2 times by root 65 times by root 50. Let's see, is 0,1315. There we go. 0,131 dot dot dot. If I then calculate angle FHG, it is 82,4 degrees. Okay. Woo! This is a lot of work. But that, ladies and gents, gives me now that angle there, 82,4 degrees. Which means I can now actually find the area. The area, which is a half times by the one side, okay, times by the other side, times by sine of the angle in between, 82,4 degrees, which means you get an answer, if my calculations are correct, 28,3 square meters. Okay. I want to just for a moment quickly talk to you. I know that this last question was a doozy. It was a tough question. But the big thing that I want to remind you of is that both IEB and GDE papers are more and more, both in paper 1 and paper 2, throwing in questions that they don't scaffold. In other words, they don't break it down. Like here, they ask you calculate the area of that slanted triangle. They don't tell you how. They just for 7 marks tell you go for it. So I encourage you. I know it's tough. Please, please, go and try this at home yourself. Try this Give it a bash. Don't be afraid. Break it down like I did. I started by asking myself, how do I calculate area? Well, I need two sides and I need an angle in between the two sides. Then I went and I broke my sketch apart into those two-dimensional shapes, which meant I could actually use in a 90-degree triangle, I could use Pythagoras. And also, then, if I've got this sides, the side that takes me from my, let me quickly go back there. If I've got this side here, this slanted one, I just forgot to put in my 90s there, my apologies. If I've got this side there, and I've got that side there, it moves me over to the actual triangle I want to work with. So my encouragement to you is really go and break the stuff down. I don't just go and run into this. I look at how do I do it, break my things apart, and then find ways of actually calculating this. I want to do one more little question. One more question simply because I'm just feeling excited to see something like this. Let's say in the exam, they give you this fx. And they give you square root 2 minus 2 sin of x minus 45 degrees. And they ask you for the range of fx. Now this question could be structured in many ways. They could ask you for the minimum, the maximum. They could ask you for the highest point, the lowest point, the range. It could be asked in many ways, but I'm going to look at specifically the range of fx. It's very easy to kind of get frightened about a question like this, okay? But if I look at a question like this, it's actually not that difficult if you know your theory. So where do I start with a question like this? In a question like this, I like to first of all just start by rearranging fx into something that's kind of a bit more familiar for myself. So negative 2 sine x minus 45 plus 2, just all under a square root. Resist the temptation, please, of breaking that thing up into the compound angles. Please, you're going to make life intensely difficult for yourself. Let's have a look at this sine of x minus 45. Is it minus? Yes. If I look at sine of x minus 45, what would be the range of that function? Well, the range of that function would be an amplitude of 1. So in other words, it won't go lower than negative 1, and it won't go higher than 1, and it might touch it. Now that negative 45, again, remember, means a shift to the right, has no effect on the amplitude or the range. Next up, what does the negative 2 do to the sine of x minus 45? Well, the negative means my graph reflects in the x-axis. Means my graph's just starting to go down instead of going up. The 2 changes the amplitude. So in other words, now all of a sudden, my amplitude goes from negative 2 to 2. That negative doesn't change the amplitude, just the direction. If I now go and add 2 to this, so now I'm going to go negative 2 sine of x minus 45 degrees plus 2. Look how I'm building towards fx. I'm starting with what I know, which is sine. Then I introduce an amplitude. Then I introduce the plus 2. So I'm building up towards fx. So in other words, now I am shifting my whole graph up to units. So in other words, now my graph lies between 0 and 4. That is beautiful because we've got a square root. If I now introduce a square root, it means all the values, all the y values just get rooted. In other words, it still can't go lower than 0 because just between you and me, it is a positive square root. But also, the highest point, which is 4, now becomes 2 because I square rooted both sides, or I square rooted the y values. And there, ladies and gents, you have your range. In other words, you have your lowest y value, which is 0, and your highest y value, which is 2. All of a sudden, not so intensely difficult. I'm not saying easy, let's just get it straight, but I'm not that intensely difficult. I want to say thank you for joining me on this lovely Tuesday evening. It was fantastic for me going through some old exam papers. I know there are some lovely, lovely questions out there. And if you've got them, please send them in. If you don't know how to get to a specific question, please don't be afraid to ask. Remember, subscribe to our channel. Subscribe to this Junior Techie channel and you will receive amazing updates, freebies. I mean, this week there was the Grade 11 Empowerment Week that kicked off with some beautiful things. Some motivational speakers talking about branding yourself, mathematical reasoning that I'm privileged to present, and many, 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 many more videos. So subscribe. Please hit that bell for the notification that you put on or turn on all your notifications. It's been an honor and a privilege doing this 45 minutes to an hour session with you. This is Sarah van Green and Mr. VG signing out. Remember, if you haven't yet downloaded the program, please download the program. Oh, and one more thing. There has been two live sessions already. One on calculus, one on functions, graphs, and inverses. Those videos are available on the Junior Techie YouTube channel. Please look below. There's a link to the program, and on that program there's videos, and there's more videos coming next week. So next week, Monday, remember here by about, let's make it midday, go and update your program. There'll be new videos, there'll be new worksheets, new memos. I'm looking forward to seeing you in about 2 weeks or so with the next live session, which will be specifically on Euclidean geometry. Ladies and gents, go and be awesome and have a beautiful, wonderful rest of your week. Good luck with everything that's on the way. Cheers.